we recently open sourced. We built it at Coinbase, and I think a lot of what has been said so far in the conference will actually resonate with this tool, talking about ways to automate security and scalably operate across lots of services. This is a tool that we built to help us do that, because basically Coinbase started expanding very quickly, but we also have really big security requirements. So this is why we built it, and now that it's open source, I hope that this is something you can use. You can fire it off today from your laptop during the presentation if you want. So a bit about me quickly. I work at Coinbase on the security team, and if you don't know what Coinbase is, it's a digital currency platform. You can buy and sell things like Bitcoin and Ethereum and other digital assets. So we have an exchange and some fancy mobile apps and things like this. And the security requirements are pretty large at Coinbase, because we're sort of this big pot of gold sitting on the internet, and a lot of the money is stored offline, but we still have a fair bit of money online. And so for financially motivated attackers, that we're one of the largest bounties online, I would say. But at the same time, we want to operate in a very agile development environment. We want to deploy continuously, and we have lots of developers writing lots of code in lots of different languages and lots of services. So security becomes a challenge of trying to be as preventative as possible and trying to enforce as many good checks in our pipeline. So this tool really came out of scaling, as I said. So for some context, I'll tell you sort of what happened with Coinbase over the last few years. So I started in June 2015, and my manager on my first day took me out for coffee and said, I want 100% of services that we deploy to have production, that are deployed to production, to have scanning of some kind. And back in those days, we had one monolithic Rails app. So this was pretty easy. I was like, all right, cool, I have one thing to take care of. The problem is that was here, and then this is the number of services we started deploying over the next few years. So this problem started getting a bit out of hand, and this is why we built this tool. So yeah, number of services, and the bar graph doesn't really show up, but these are all in different languages and on different frameworks and things like that. So quick review of scanners. I think a lot of you already know how security scanners work and know many different types, and I've learned about some during this conference, which is great. But I will quickly review security scanners and sort of what I expect out of them input-output wise. Some problems with security scanners that you might have when you're trying to deploy them at scale, and then we'll talk about what Salus does, how it solves this very problem. And then I'll actually go into sort of, oh yeah, also, as I said, it's like free. You can run it directly. I'll show you a command to run it in a moment. You can run it on a repository you might have locally. And then we'll talk about some of the cool things you can do with Salus, how you can configure it, how you can use it in your infrastructure, and then I'll just point to like the resources so you can check it out as well. So software scanners. Very quickly, I think of a scanner as just some piece of software that analyzes some other piece of software. It could be linting, it could be looking for CVEs, it could be doing all sorts of things. So basically you have some source code that is ingested basically as an input. The code is the input to the scanner. It will pass or fail. Hopefully if it fails, it tells you what's wrong with your code. And then you have a feedback loop where the failure message can go to the developer can fix their pull request, and then they can merge hopefully compliant code into the master branch. So a good example of this is in Ruby land. There's a lot of Ruby at Coinbase, so a lot of my examples will be Ruby-based. So linters, not necessarily security related, but it's a type of scanner. RuboCop is sort of the go-to Ruby linter. You take some piece of code. This is actually some piece out of Salus that's arbitrary. You put this through RuboCop. It will say, hey, this string here should be frozen because you're treating it as a constant, and it should be immutable. Go fix that, and then you have that feedback loop. We've talked a lot about CVE scanners. Another example would be, again, just in case you don't know what it is, some documented vulnerability. So CVE scanner looks at your dependencies. Bundler audit is the way to do this with Ruby gems, which is the libraries in Ruby. So you could say, let's say we're including in our project active support 3.2.10. Bundler audit will look at this thing and then find out, hey, there's this known vulnerability, it came out in 2015. You should upgrade this thing. And again, you have that feedback loop. So these scanners are really good, and I do recommend knowing which scanners are relevant to your frameworks. And as Liz said 2 speeches ago, this will probably save your ass one day. So scanners are really important. I think, firstly, CVE scanners can be quite powerful. every year, Verizon does a big analysis of lots of breaches, and they collect a lot of metrics on them and how they happened. And in 2015, their statistic was that 99.9% of exploited vulnerabilities were from CVEs that were out for about a year before the actual exploit. So just by cleaning up your stack from CVEs should probably prevent a lot of possible attacks. And then in 2018, they basically said the same thing, and for every year in between. They just gave a list of tips this year, but like one of the things they said is, you know, cyber criminals are just using known vulnerabilities. Not just, but I mean, usually they are. If it's a nation state which is using 0 days, you've got some bigger problems, I would say. And then, so you can guard against these by upgrading. So scanners for CVEs are very important. Other types of scanners, they'll look for anti-patterns. So for example, using eval in many different languages, including Ruby. If that's on user-controlled input, you'll get an RCE. That's not good. I also like scanners because they're not fatigued like humans, especially when it comes to like ship time and everyone's trying to push out code really quickly. Scanner operates the same every time. So that's very important. You can run them on every build, and you can run them around the clock. This also ensures that you have some sort of baseline for the health of all your services at every point in time. And the last thing to say is these are not silver bullets. And I think Nick, the last speaker, said this as well. Like, you should probably use scanners in tandem with human reviews. Or at least I would recommend that. Humans are very good at analyzing things like business logic or custom modules that a scanner might not pick up. Usually, I would say, especially the non-CEV style security scanners, the ones that are looking for SQL injections or remote code executions, stuff like this, they tend to work strongest for frameworks which are most rigid. So for instance, Rails is a very rigid framework to build a web application. There's like a Rails way to do things, and if you don't do it the Rails way in a Rails app, you'll probably just waste a lot of time. Now, rigidity is not good in all cases, but for security, it's actually really good, because that means that President Beef, as he's known online, can make the Brakeman scanner, which is incredibly powerful at looking at how data passes through an application and then working out if you have a remote code execution or if you have SQL injection or anything like that. So yeah, it's worth knowing which scanners are available, and rigid frameworks, I think, actually tend to do pretty well with scanners. So how might you deploy a scanner? You've decided scanning's really good. How are you going to run this thing in your infrastructure? So the first thing you can do very easily, but not very maintainably, is to just run it on the repository. So you download, bundle, or audit locally. You go to the repository that you want to scan, and you just run bundle, audit, check, and it gives you output. Great. So you can now, as an individual, scan each of your repositories. The issue with this is that you kind of have to do it manually every time the code changes. So that sucks. You could do this slightly better if it was a pre-commit hook, maybe, but then you have to control the development environment of all your developers, and that's not good. Usually developers are very particular about their environments, and I prefer at least a work culture where you can sort of have your own development environment, use whatever you want. And instead, I think what's a better idea is to just put these scanners in the CI/CD pipeline directly. So I kind of think of you know, your builder, or the thing that runs all the tests internally, as sort of like doing pre-flight checks before you put something in production. So it's just like an aircraft who's checking all their flaps and their ailerons before they take off. So instead, what you can do is just run the actual scanner, in this case Rubocop, the linter, but it could be anything. You could run it in the test suite itself. So this block of code here is something we used to use to run these scanners in the test suites themselves. So this code, it looks kind of weird, but it's RSpec Ruby testing framework, and you can execute anything in there, including your security scanners. So you could go around to every repository and just add a test, which is like, run this scanner, and if the scanner fails, fail the test suite, and if the test suite fails, then the build will fail, and if the build fails, you probably shouldn't push it into production. So this is a pretty good way to ensure that you have continuous monitoring on every pull request. And so this worked for a while. And basically, we had a situation where you have a developer. In all my slides, developers are these fairies, just cause. And so you have a developer, they push to source control, that thing gets run on a CI server so that you can run the test suite, and that's where you can stick these security scanners, and if there's a failure, the developer will see it, they'll fix their pull request, and eventually that makes its way into the cloud. Cool. So this pipeline works well or it did, when we had one massive monolithic Rails app and I had one code base to look after. The problem is that we started scaling. And suddenly I had to replicate this block of code over and over and over again into lots of different repositories. And to get this like 100% of services deployed having scanned metric work meant that this started breaking down a lot. Because basically you ended up with a situation where you had, if you had M scanners and N code bases, you had to use M times N code blocks. And anytime you wanted to change anything, upgrade the scanner version, test out a new scanner, decide one scanner is useless and you're going to replace it with something else, you would have to make M times N code changes. And this definitely did not scale. So I wanted to avoid asking all the service owners to do this for me. I didn't want to have to just email the dev listserv every day and say like, hey, please update to this version of the scanner. One, because that's a lot of work for teams that really is, I would expect the application security team to do. But also there's sometimes a lot of context that's required to understand how the scanner works, how to configure it correctly. It's really easy to misconfigure a lot of these scanners so that they either just softly fail or they just don't actually scan what you think they're scanning. So this sort of just put a lot of burden on the application security team. So I thought, well, I guess I'm going to have to do this myself. Once we started scaling, that's what I looked like. It was not fun. So thinking back to David Wheeler, this is probably one of my favorite quotes. All problems in computer science can be solved by another level of indirection. David Wheeler was a professor of computer science, I believe, at Cambridge, like not far away. I think the only case which this is not true for is too many levels of indirection, which can actually be a problem sometimes. So instead, what we decided to do was we would build this thing called Salus, and it would run all the scanners and configure them and work out what to do. And instead, each test suite would just run latest Salus. And so you now replace this block of code with a big Docker container instead, and that is like now your pointer to everything that you actually want to do. So kind of like Nick was saying in the previous presentation, add a level of indirection to take care of authentication in a global way. Well, this is kind of doing that, but doing it with security scanners instead. So what exactly is Salus internally? So as I said, it's a big Docker container, and it has two components in it, well, many components, but let's say two. One is the Ruby application itself, and this is just a small blob of code. I mean, it's a bunch of files, but it's a blob of code that will coordinate scanners. It basically looks at the source code and decides, is this a Ruby app? If yes, maybe I should run this scanner. Is it a Rails app? If yes, I should run this scanner. Is it a Node app? If yes, I should run this scanner. And then it also has all the scanners installed for many different languages. And on the right side, I kind of have the repository sitting there. So that's probably on the local file system of the CI server or wherever you're running your test suite. And you volume this thing into the container so that Salus can then actually analyze it. So this is the magic command right here. You could run this right now on a repository you might have locally. And Coinbase/Salus on the end there, that is sitting on Docker Hub right now, so you can pull it directly. So I'll actually just run through this command, because that basically explains how everything works. So Docker run, that's like your one dependency that you need to run this thing. You will need Docker. --rm, just because this container is irrelevant after it runs, so you can delete it. -t, so that you attach your terminal and you can see the output. That's probably useful. This -v is important. This is voluming in the current directory that you're in. Presumably you went to the directory you want to scan. And home/repo is just a magic path. That's where Salus expects to see the source code it's going to scan. And so you volume in the repository, and then it just executes in the Docker file for this thing. There's an entry point which kicks off the Salus Ruby application. So once you run this thing, you get some text output, and it kind of looks like this. So I ran Salus on itself, actually, and it decided to run bundle audit because it has some Ruby dependencies. It passed. It also happens to have some Node dependencies, so that passed. Pattern search, I'll go over that in a minute, but that's basically like grep or looking for anti-patterns. You can define an arbitrary list of regexes, and if it finds them, it could fail the build, or if it doesn't find them and you require them, it can fail the build. Repo not empty. So we had this interesting case where due to some rather complex infrastructure issues, which I won't go into, there was this point where we accidentally scanned nothing. We volumed nothing into the repository, And so Salus just passed on every possible run because it found no errors because there was nothing to scan. So this test literally just checks that you have at least one file to scan. Strong defaults are something we like in security scanner land, so we put that in there just to make sure if you accidentally misconfigure something, Salus will throw an error. And then the last two things, I'll speak about that as well a bit later, but we found it very useful to also report all the dependencies that a project is using. And we have a way to ship that into our logging pipeline, and this should be easy with Salus to do in your infrastructure as well. And then, as some speakers have talked about, if you know all the dependencies that are running across all your services, it's then very easy to go into incident response mode once you get a CVE that comes out. So, sort of recap of what I was saying. Ruby application will start by initializing configuration, and there's a lot of fancy things you can do with it, so I'll go over a few of them in a minute. It loops through each of its scanners that it knows about. Is it appropriate to run this scanner? If yes, run this scanner. It then compiles all of the outputs of these things and puts them into a report. And this will go to standard out by default, but you can also post that report in multiple different formats to an HTTP endpoint if you want. So if you have an internal log consumer in your infrastructure, you can send all your Salus reports there, and then depending on what you're running, let's say you're running Elasticsearch or something, it can conveniently index everything and keep it there so that in the future, if you're like, oh wow, there's a new OpenSSL bug, who's using OpenSSL, you just query Elasticsearch and you'll find your Salus reports and it will tell you which services are running OpenSSL. And useful for CI pipelines, it will exit 0 if any issues are found. Usually a test suite, if it sees something exit 0, will just fail the whole build, so it's useful for that. So remember this situation I said? I had a lot of code changes to make, and we were scaling too quickly, and I couldn't keep up, and I was not happy about that. So now, with Salus, I make one code change. I have an internal Salus that everyone pulls into their test suite. If I want to update something or test something, I just change that one code base, build the new Salus, push it up to the registry, and then everyone pulls that down. So this is kind of what it looks like now. Container registry, or the thing that's hosting the configuration file. I'm happy now because I can make one change and roll that across the whole fleet kind of instantly. So that's like, there's no massive magic here. Like all the scanners, and not all, but most of the scanners inside of Salus are just other open source projects. This thing is all about how you coordinate that at scale. So, and actually sort of as an example, we happen to run Circle CI internally at Coinbase, but you might be running Travis or some sort of other building platform. If you are using Circle, this is a small piece of what they had these concepts called workflows. So this is literally all you have to add to your Circle file to run Salus in your infrastructure. You just check out the code and then you run it, and then this will run in parallel with all your other tests. And then on your pull request, you just get some statuses. So this is again Salus running on Salus, but for this particular instance, Circle had 3 things to do: run the linter, run Salus, and run the tests. And then if something was to fail, you could then look at the details link. Salus would have output that can then tell the developer what to do. And I remember there was actually one of the speakers, I think the first speaker of the conference, talked about how a lot of the scanner outputs sometimes make not much sense. So Salus is sometimes an opportunity to shim that away from the developer and put your own language in there to sort of help them fix, self-service their issues. So I'll go into Salus configuration because when we first started working on Salus, there were a lot of reasons why we couldn't roll it out across every code base, and that probably also applies to different infrastructure and different organizations. So my hope is that all the pieces of configuration that you can use make it possible to use in your infrastructure, and especially across every repository. So as I said, the first thing that is important to realize about the configuration is you can turn on and off scanners. So by default, every scanner that it has, it will just run it if it seems appropriate. And these are the ones that are currently supported. Liz just spoke about gas for Go, which is great. I'm just learning about it now. Probably tomorrow I will make a pull request into Salus to put gas in there, so that can be rolled across the whole fleet as well. So here are the scanners that exist right now. Everything will run by default, but you can say, don't run this thing because I don't think it's a good scanner or whatever. You can also choose what will actually fail the build if one of the particular scanners will fail. So the way you would do that, each scanner also has its own configuration. We'll get to that. So you have a config flag. Making the Docker command slightly more complex, you can give the config flag and just point to a particular file. Salus configuration is just a YAML file, and this will tell you, or you can tell it what to run. You can also, if you just have a salus.yaml sitting in your repository, it will automatically look for that, so that's an easy way to do it. And if for some reason you would like to use an environment variable, you can use that as well. So basically, here's like a block of YAML which could be valid Salus configuration. You could say, active scanners, I only want you to run pattern search and npm audit, and the only thing I'm going to enforce is pattern search. So only if one of the regexes that I looked for, maybe it was dangerously set in our HTML in a React application or something, if you find that thing, then you can lead to a non-zero exit status. And if npm audit happens to fail, then for some reason, you probably should care about that failing, but if for some reason you didn't, it wouldn't be enforced here. Cool. That was more for local configuration, but how can you do global configuration? So as I said, we like to know that the entire organization is adhering to some sort of security policy and some sort of standard. So what you can do is also just host this YAML file at some endpoint. Like, we could just be an S3 bucket, could be anywhere. And Salus will actually just pull the thing down from that URL and then pass that configuration and use that. So this is a really easy way to sort of start upgrading things across the fleet. The configuration file can also host these regexes, let's say, that it's looking for when it runs the pattern search scan. So if you decide, it turns out that a lot of our developers are making this one mistake over and over again. They keep using, they keep using backticks in Ruby to shell out to CD instead of just using chadr, which is a native thing you could use in Ruby. So we're now going to look for backticks, and if we see that, we're going to flag it, and you can put a custom error message in there as well, so that the developer knows what's wrong. So this is what's really useful about these global security policies. It's also especially useful if you want to test out something new. So you might say, we want to try this backtick example I just sort of gave, but we don't know if this is going to just fail every build and every developer will get very angry. So something I'm always cautious about whenever I change Salus is, will this actually break a lot of builds and then surprise lots of developers? That's never a good position for your security team to be in, because you always want your security team to be liked by your developers as much as possible. So what you can do is put something in soft mode. You launch it on this global configuration and you say, if you find this, tell me about it and put it in the report, but you can let the builds continue. And then you can collect all the metrics and just see if any repositories are failing. If they are, you can work with the developers to fix them. And then when everything is green, you can make this an official enforced check and go forward. And now everyone is at this higher level. So what happens if you have a global security policy, but then it turns out one of the repositories must have an exception? And this tends to happen a lot. So for instance, you might say, thou shalt not deploy if there is a CVE in one of your dependencies. But then there's this one repository over here. It needs this package, and there's no patch for it, but it does have a CVE, and you have definitely worked out that you're using the package in such a way that your application won't be vulnerable, even though that there's a CVE there. If this is the case, or there's one of many other cases that leads to exceptions in the rules, you can actually concatenate these configuration files. So you can have the global security policy be passed first, and then a local configuration file can go on top of that, which can include exceptions or overwrite pieces of the previous configuration, so that you can still have Salus on every repository, but still allow for these sort of like local exceptions here and there where it's necessary. So this is something we use a lot to make sure that we can still maintain 100% Salus coverage, but compliance sometimes needs gaps in the policies where appropriate. So custom Salus. The Salus that is open source has scanners which we thought would be useful to many organizations, and as I said, we hope to expand this over time. But it doesn't have some scanners that we probably use internally at Coinbase which are not useful for anyone else. And there may be some things you want to check for internally as well, which are maybe more complex than just looking for regular expression, maybe an actual scanner that you want to run or you've built internally or something like that. So it's very easy to customize Salus as well. You can build your own Salus container with a Docker file with just 2 lines in it, basically. You just write from Coinbase Salus, and so that's the actual container that you're going to be inheriting from. And then you can copy in some arbitrary list of scanner files that you've written. So this could be an example of one. An example here is, let's say you want to check that every Docker file pins the SHA, or pins the container that it inherits from. You could write a small bit of Ruby to check this logic, and then you can just build a new container with that, and Salus will pick up your Ruby file and just execute it as part of the container. So that's pretty useful. Like, all you have to implement is the run command and the should run * command and or method, and off you go. So it's highly configurable, which is useful. So we have the open source version, and then we run an internal version with some Coinbase specific logic in it, and one inherits from the other. So I talked about custom error messages. This is the output from the CVE checker in Ruby bundle audit. Now, to me, because I've been working in security for a while, all of this makes sense to me, and it probably makes sense to everyone in the room. But I know that a lot of developers sometimes get this error message, and they're like, what does this mean? Like, what is CVE? Why am I being linked to Google Groups and like denial of service I've heard of, but I don't know what it is? So you can also use Salus to wrap these messages kind of nicely and then give them next steps, or maybe give them points of contact that they can speak to, which is something else you might use Salus for, maybe purely just for the messaging point of view. I think the better the messaging, the more self-service your security can be for developers, which gives you more time, I think, as a security team to focus on other issues. So let's talk about Salus reports. So Salus is pretty verbose in the amount of data it collects. It will firstly collect which scanners passed and failed. That's probably important to know. It also will collect any reasons that it failed. As I mentioned before, it also collects all the dependencies, or at least looks at the name and the version and the source of each dependency that's being pulled into a project. So I think right now that works for Go, Python, Ruby, and Node. So it collects all these dependencies, makes a big list out of them. The report will also include the configuration that Salus used. And then you can also tell it where to send this report. So maybe as part of your build pipeline, you want to create a text file as an artifact. Maybe this is useful for the developer to look at. But then you can also post these reports to some arbitrary endpoint. Don't send to this endpoint. This is a made-up endpoint, internal.net. I don't know who owns that domain. They probably don't want to receive your Salus report. But you could probably have an internal log consumer that you can send this thing to. And you can specify the format as JSON. That's probably what you want if it's an API, but it could be YAML or it could be text. And then once you consume these logs, you can start to do lots of fancy incident response with it. So as I said, reports, like by default, standard out will be printed. The text file, that might be used for a CI artifact. And then this is good for remote consumption. On the left, you see a text blob, which is maybe what the text output would look like. And on the right side is just it's the equivalent report, but just in JSON format. And then the useful thing is once you ingest this thing into your log pipeline, you can look at things like which dependencies are we using. And so as I said, so we run Kibana on top of our Elasticsearch cluster. And this allows us to easily query who's using what dependencies, if a new CVE came out, or if we've worked out that maybe there's a new type of vulnerability in Rails and only the latest version of Brakeman happens to look for that vulnerability, we can quickly query which Rails applications are not using the latest Salus and haven't checked for this thing yet. And then we can easily move into incident response mode. So that's very helpful for those sorts of things. So other resources you can look at, as I said, we recently open sourced this thing. You can go to Coinbase/Salus on GitHub. You can find it. And as I said, on Docker Hub, the thing is hosted. So you could build it and run it. And if you're security conscious, that's probably a better thing to do than just pulling it from Docker Hub, because you're not really guaranteed of the supply chain there. But if you want, you can just pull it from Docker Hub, or you can pull it from Docker Hub into a registry and then just pull that thing down. That's probably the most secure practice. And we recently launched a blog post about, releasing this product. You can read that blog post if you missed anything in my talk. It's roughly the same information. So a bit of a summary. Why is Salus useful? It's something you can inject into your CI pipeline. If everyone just includes Salus once, you can now roll things out across the whole fleet with a single configuration change or a single code change to the Salus container, which is very useful. That keeps your security team happy and light and scalable and gives them lots of metrics. And it also still ensures that you have that tight feedback loop with your developer. And I think you can actually improve that feedback loop with your developer because you get the ability, or you have the chance to inject custom messaging in there, which can sometimes be very useful. Final note, I just want to say thank you to the open source developers which make these scanners. We leverage a lot of open source software in general. I think most companies do, but the amount of, I say, additional speed or comfort we get from these open source scanners is tremendous. So huge shout out to the people who make those things. Ryan, Adam, and Slava helped me build this thing, so I thank them a lot, and DevSecCon organizers for making such a great conference. Cool, that was pretty fast. I actually have 9 minutes for questions if anyone has anything.
Any questions? Nope.
Sweet. Yeah, thank you so much.
Thank you.